life of Steve Squyres. I'm ready to move on. You, sir.
My question is for both of you. There was a 7-month gap between launch and landing on Mars. What exactly did you guys do?
George, start, and then I'll tell you mine.
I worked in another movie. Actually about John Kerry, and I'll tell you just a little bit about it. I met John in 1964, and he's one of my closest friends. And I made a movie called Going Upriver, The Long War of John Kerry. The first half of the movie was about his combat in Vietnam on the rivers and the swift boats. And it would have blown away the people from Texas who brought him down in the middle of his campaign if he had shown the film. Because I interviewed everyone who was on John's swift boats, and they all said the same thing about the conditions under which he won his medals, which was a major objection to the swift boat people from Texas. And he literally could have won the election if that film had been shown around the country. You just don't get all the breaks when you need them every time.
I spent that 7 months with my team earning our Martian driver's licenses. When we launched those rovers, we didn't have a clue how to operate them. Just not a clue. In fact, I got to tell you, a substantial fraction of the software for driving these things had not even been written and tested when we launched them. We launched them with the software for launch, cruise, and landing on board the spacecraft. But 5 months after we launched it, the nice thing about software is you can launch the rocket and then you can launch the software later, and it travels at the speed of light and it catches up with the spacecraft. So we actually didn't get the driving software on board the vehicle until 2 months before landing. We were very, very busy for those 7 months.
Madam.
What's your plan or prediction, realistic prediction for return and the manned mission?
For a sample return and a manned. Wow. What is my predicted date for a sample return and a manned mission? You know, sample return has been 20 years in the future for the last 20 years, so. But I don't want to say 20 years. You know, I honestly don't know. It's not a scientific question. It is not a technical question. It's a political question, and the political landscape changes with a time scale that is short compared to how long it takes to do a project like this. So, you know, when the community rises up and says we want to see this happen, when the nation comes together and says we want to see this happen, then it will. We know from history that you can go from a speech to footprints in 6 years in the case of the moon. It shouldn't take us 50 years to get to Mars. How long is it really going to take? I'm not even going to try to predict.
The red shirt.
I wanted to know if there was a way to keep the dust off the panels, and if you use atomic energy power, would you then not need panels?
Okay, good questions. Yeah, the question of how to keep dust off the solar arrays is one that we looked at very extensively as we began designing the rovers. We looked at many possibilities. We looked at windshield wipers. We looked at compressed gas jets that would blow stuff off of it. Somebody even suggested electrostatic levitation. My personal favorite was like clear plastic, you know, like saran wrap on rollers. And then when it gets dirty, you turn the rollers and clean plastic comes across. It's not a bad idea, actually. The problem with every one of those is that they require some heavy, complicated mechanical gadget to do the job. Okay, that windshield wiper would have been bigger than my instrument arm and all the instruments on it. And we were right up against the stops for how much mass we could send. So what we chose to do instead was the simple brute force approach of making the solar arrays bigger than they needed to be. We made the arrays as big as we could possibly make them. When those arrays are totally clean, we have to shut the rover down for an hour and a half or 2 hours every afternoon to let it cool off to keep it from overheating. They put out so much power. And so that simple brute force approach turned out to be one that worked pretty well. If you send a nuclear power source, does that mean that you don't need solar arrays? The answer is it depends. Depends on how powerful your nuclear power source is, depends on how much energy your rover uses, depends on the environmental conditions in which you land, and many other things. They are currently, actually right now, looking at adding supplementary solar arrays to the MSL rover as a way of boosting the power on that vehicle. Looking at it. That hasn't been done yet.
The wonderful thing about standing here and looking at your faces is the intensity of interest is so strong here. I really believe that the space program is what America does best. It's a wonderful act of collaboration. And I watched Steve go through it very intensely with a lot of his associates. And this is a magical story that we're dealing with. I feel very strongly about that. So I hope I can get my science lab film financed and underway soon. Next question, in the orange shirt.
I just wanted to see, I know you probably don't want to make a prediction, but how long do you think the rovers will last?
How long will the rovers last? When is this going to end? My wife keeps asking me that question. I have no idea. The only way that you predict, in any realistic sense, the lifetime of spaceflight hardware is by doing life testing of components. You take critical components and you test them to failure. Now, we had a design requirement of 90 sols, 90 Martian days on the surface. So being conservative scientists and engineers, we tested all of our mechanical parts to 4 times that. We tested our electronic parts to 3 times that, 270 sols. We thought that was a pretty big number at the time. Well, today is sol 19, I don't know, does anybody know? Spirit? I think it's 1990 something today. Anyway, what? 1982. See, I've been traveling. We are doing life testing of components on the surface of Mars now. And they're going to die when they die, and it could be tomorrow. It could be 5 years from now. We have no way of knowing. We push them as hard as we can, and we treat every day as a gift. That's all we can do.
Sir, you.
Oh, just a simple question. You mentioned your wife was complaining about your involvement with this. Does it mean you live on Sol time? And if so, what time is it really in your world?
We are fortunately not living on Mars time anymore. We lived on Mars time for about 4 months. The Martian day, as I'm sure most of you know, is 24 hours and 39 minutes long. And that just plays hell with your life if you try to live that schedule on Earth. If you try to live it on Mars, it wouldn't be a big deal. Okay, but trying to live it on Earth can be difficult because, you know, if our daily planning meeting starts at noon today, then the next day it's going to start at 12:39, and the next day at 1:18, and 2.5 weeks later you're having your meetings in the middle of the night. And then this, of course, was that I had 2 rovers. So I had to split my team in half, and everybody's living on Martian time, but in 2 different Martian time zones. And if you're working on one rover and you switch to the other, you get Martian jet lag. So it was a very, very bad way to live. We did that for 4 months, and the team just couldn't take it anymore. And so we've been living on kind of a modified quasi-Earth, quasi-Mars time ever since, where we sort of follow Mars for a while, but once it gets to the point where we're staying up too late, we kind of snap back and wait for Mars to come around and catch up with us. And during that catch-up period, which we call restricted sols, what that means is you can't drive every day. You have to plan each day not on the basis of what happened yesterday, but on the basis of what happened the day before, because you haven't got the data yet. And it's cost us some time, but it's sure saved us some sanity. Probably saved a few marriages, too.
I think we'll do about 3 more questions. You, sir.
Steve, I wanted to know what you and your wonderful team are going to be doing when the spacecraft finally do die.
What are we going to do when the spacecraft die? Well, the short answer to that is we're going to finally start doing all the things that we thought we were going to do back before the mission went on so much longer than we expected. But I think the real thrust of your question is, what's it going to do to us? Okay? I don't know. I honestly don't know how I'm going to feel. I have found consistently that trying to predict my emotions, my feelings, how the team would react at various points during the mission, I've been wrong numerous times.